the next topic is the nth roots of unity. Okay, nth root unity. So let's try to define the nth root of unity first. So when we considered the third root of unity, cube root of unity, uh, we used to take cube root of unity and we got three different answers, correct? So there were three values like 1, omega and omega square, right? Now also we are going to apply the similar concept. When I try to take nth root of unity, I'm expecting n different answers, right? Cube root of unity gave us three answers. So square root of unity, there are two answers. Similarly, if you are calculating nth root of unity, you are going to get n different answers. This is what is expected. Okay, so okay, let's write something now. Let say x is my answer. This be the nth root of unity. So this means x is equal to 1 raised to the power 1 by n. But I know 1 can be written as simply this is cos of 0 degree plus I sine of 0 degree whole raised to the power 1 by n. Right. So 0 degree is same as I am incrementing every time 360. 0 is same as 360, which is same as 720 and so on. You keep on adding 360 degrees to that, or you keep on adding 2 pi radians to that, there is no effect. So this means I can further write this as the cos of 2 pi times k is an integer, 2 pi k plus 0 degree or 0 in radians plus I times sine of 2 pi k plus 0, right, whole raised to the power 1 by n. Right. So this means I can simply write this as cos 2 pi k plus I sine of 2 pi k whole raised to the power 1 by n, right, is same. It's going to be the same answer. So that means I can write I sine to the power sine of 2 pi k to the power 1 by n. Okay, so now we know that we already have come across the de Moivre's theorem, which says that raising to the power 1 by n means that n can come inside the brackets, right? So this is cos of 2 pi k divided by n, because that 1 by n comes inside the bracket as denominator, n in the denominator. Okay, so therefore we can write this itself as plus this is I into sine of 2 pi k by n. Okay, so this is x, and I'm trying to find the k will be, what is k? K is 1, 2, 3, etc. Right? All possible integer values. Right? Up to will substitute n minus 1. Right? K will be substituted as 0. Okay, so not just 1. It is starting from 0. 0 to n minus 1. Because even 0 degrees is an answer. So inside the bracket, if you want to get 0, it has to be 0. K is 0. right? K0 means cos 0 plus I sin 0. Next, K is 1, and another number. K is 2, a different number, and so on. All right. So this is the equation. The first equation which we have written over there is the one which gives us the x value, which is the nth root of unity. N value comes into picture. Uh, if you are trying to find the seventh root of unity, you put n equal to 7. Okay, in this particular equation. All right. Now let us try to give another notation here. That is, if we have n roots of unity denoted by, let's try to give a alpha value here. Okay? So let me highlight the result first. This is the result, right? Nth root of unity is given by this equation. All right, let's proceed further. So in this case, let's denote alpha as the one which we got as answer, that is cos of 2 pi by n plus I sine of 2 pi by n. Okay, it's the same. We are using this from the previous equation. So you can see that there is no k, right? We removed this k and we are writing this part. So in the above equation we have k, and in the current equation I am not considering the k. All right, so let us assume that this is called as alpha, and we try to put k now, because k varies from 0 to n minus 1. Okay, this implies if I use alpha is equal to cos of 2 pi by n plus I into sine of 2 pi by n, then the nth root x is nothing but alpha to the power k, right? Because alpha to the power k is this raised to the power k. K comes back into place, right? So if you have cos theta plus I sin theta raised to the power k, it can be written as cos k theta plus I sin k theta from, right? That's very basics. We already know that. So we use that particular property over here, and we try to write the nth root x can be calculated by using this particular method. Alpha is whatever we have assumed as alpha, we can use it to represent that. Now let us try to do slightly more analysis of this particular alpha. Okay, now we know that what are the different nth roots of unity, right? All the nth roots of unity x given by alpha to the power k, and we already know that this k varies from, right? K varies from 0, 1, 2 up to n minus 1. So this means, right, you can see when you put alpha equal to 0, when you put k equal to 0, x becomes equal to alpha to the power 0, which is 1. When you put k equal to 1, x is equal to alpha. Then when you put uh, k equal to 2, this becomes alpha square. Last number is power n minus 1, that is alpha to the power n minus 1. Right? If you see this, it's a specific type of progression, right? This progression is called as, there is a constant ratio. So they are in geometric progression. It's GP, right? And if that is a case, right, we can try to find out the sum of nth roots of unity, because sum of a geometric progression is what is very standard, right? We already have done it several times so far, and it's very straightforward. So therefore, so now the first common point which comes into picture is sum of n, sum of all nth roots of unity. We'll try to calculate that. So that means, that is, I'm supposed to take the product, take the sum 1 plus alpha square plus dot 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 up to alpha to the power n minus 1 is nothing but, write the first term into, right, 1 minus, right, that alpha to the power n, there are n terms, whole divided by 1 minus alpha, right, by applying the equation, right. Now, so this means, let's try to substitute this. This is equal to 1 minus, I have to write that alpha to the n, right? Alpha to the n is nothing but, this is cos, right? What is alpha? Alpha is cos of 2 pi. Let's write that. Cos of this is 2 pi by n plus I times sine of 2 pi by n whole raised to the n, right? Because this is 1 minus alpha. E 1 now will bardilla, right? So because it is, anyway, you are multiplying by 1. So it's not required. Okay, that's fine. And this whole thing divided by, let's write 1 minus alpha. Okay, so this whole thing divided by 1 minus alpha is once again the same thing, cos 2 pi by n plus I sine of 2 pi by n. Okay, now let us try to substitute. When you have a power n, this n gets multiplied inside the brackets, right? A bracket ಒಳಗಡೆ n ಅನ್ನೋದು ಬರುತ್ತೆ, because that's what the rule says. So let's do this. This implies, now this is equal to 1 minus okay, so this is equal to 1 minus cos of 2 pi by n into n plus I times sine 2 pi by n into n. So n cancels, n cancels. So you have cos 2 pi and this. So denominator anpuna 1 minus alpha antane barutadi. Anyway, it's fine. So anyway, that substitution is not required as of now. So 1 minus, so you see cos of 2 pi is 1 plus I times sine of 2 pi, which is 0, whole divided by, this is 1 minus alpha. Okay, now you see the numerator becomes equal to, this is 1 minus 1 divided by 1 minus alpha, so that is equal to 0. So the point to be remembered here is 1 plus alpha square plus alpha cube dot 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 up to alpha to the power n minus 1 is nothing but, that is equal to 0. Sum of all the nth roots of unity is equal to 0 is the first point to remember. Okay, then the next concept to remember is the product of nth roots of unity. Product of nth roots. All right, so this means my interest is now to take this product 1 into alpha square into alpha cube into dot 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 up to alpha to the n minus 1. This is what I want to calculate. Now I can write the first number 1 as alpha to the power 0. Okay, so this can be written as alpha to the power 0 plus alpha to the power 1 is there. So this is 0 plus 1 plus alpha square, which is 2, plus alpha cube, which is 3, up to n minus 1 terms. So you can see that the power is a sum of first n minus 1 terms, and it's actually a arithmetic progression, right? So alpha to the power. So what is the sum of first n minus 1 numbers, right? It is alpha to the power. So it's very clear now, alpha to the power 1 plus n, 1 plus uh, 2, 1 plus 2 plus 3 plus 4 dot 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 up to n minus 1 is nothing but n into n minus 1 by 2, correct? So this is n into n minus 1 by 2. This is in the power. Okay, so that means this is equal to, replace alpha. Alpha is cos of 2 pi by n plus I into sine of 2 pi by n. Now this thing I want to raise it to the power n into n minus 1 by 2. Okay, this whole thing we are supposed to raise now. So we are going to raise it to the appropriate power, and that power is n into n minus 1 by 2. Okay, so that means let us substitute. When I try to write n into n minus 1 by 2, and I try to bring that inside these brackets, right, I'm going to get a simplified answer. Okay, and that value is, just a second, this is n into n minus 1 by 2 in the power. Okay, so that means this is equal to cos of, there is already 2 pi by n. I'm going to multiply n into n minus 1 by 2 to this, plus there is I times sine of, once again, 2 pi by n into n minus 1 by 2. So we can see that the n cancels, 2 will cancel. So 2 cancels, n will cancel. So after cancellation, the simplified term should be cos of, there is n minus 1 into pi plus I times sine of, this is n minus 1 into pi. All right. So now I do the reverse calculation. This can be written as cos pi plus I sine pi raised to the power n minus 1. Right? Inside the bracket, I can see the n minus 1 common for sine as well as cos term. So I can rewrite this as cos pi plus I sine pi raised to the power. Try to raise this, I sine pi to the power n minus 1. So it's very clear now. This is equal to cos pi plus I sine pi is nothing but minus 1. Minus 1 to the power n minus 1. All right. So the product of n number of nth roots of unity comes to be equal to minus 1 to the power n minus 1. So this is the next concept that we are to remember. All right. Then let's go to the next concept under this. That is, All right. Then we already know one point. That is 1 plus the alpha plus alpha squared plus dot 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 up to alpha to the n minus 1. This is equal to 0. We already know this, right? This means I can I can shorten this equation by using a summation. Summation k is 0 to n minus 1. Alpha raised to the power k is equal to 0, because left hand side, this whole thing is a summation, sum of alpha to the power 0, alpha to the power 1, alpha to the power 2, starting from 0 till n minus 1. Okay, so that's what is the meaning of this equation. All right, now let's try to substitute the value of alpha. So in this equation, if I try to substitute back the value of alpha, then I'm going to get the following equation. That means this is equal to, this implies, so let me put the alpha back in place. So what is alpha? Alpha is nothing but cos of 2 pi k by n. Okay, let me put the summation first. That means summation k is equal to 0 to n minus 1. What is alpha? I'll substitute. Alpha is cos of 2 pi k by n, 2 pi by n. Oh, k is there outside, so let's keep it as it is. So plus I into sine of 2 pi by n raised to the power k is equal to 0. Right? Now this means definitely I can bring the k back. So summation k is equal to 0 till n minus 1 cos 2 pi k by n plus I times sine of 2 pi k by n. This is equal to 0. All right. So now you see the summation. If you have a bracket, you can bring the summation inside the bracket. And if you have a plus in the middle, you can actually split the summation into two parts. All right. So therefore, we apply that rule, and I can see that the summation, right? I have summation k0 to n minus 1, and there is a bracket. So I can bring the summation inside this bracket, as well as I can split the summation because there is a plus in the inside the bracket. So because of that, we can try to write it in this way. So when I bring the summation inside the bracket now, this is what is going to happen. So this implies now summation will get split k0 to n minus 1. This is cos of 2 pi k by n, first term. Okay, plus then we have another summation coming up. I, the imaginary part, will write it outside. So plus I into summation. Once again, this is k varying from 0 to n minus 1 sine of 2 pi k by n, right? And the right hand side is equal to 0, right? Since the right hand side ಅಲ್ಲಿ ಯಾವುದೇ term ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ the sum itself is generating this answer, right? So you can write it as 0 plus I into 0. So right hand side, whatever we have, we can write it as 0 plus 0I, correct? So which means I can compare the real and imaginary parts on both sides. So by comparing the real and imaginary comparing the real and the imaginary on both sides of the equation. Okay, real and right on both sides, which means I'm trying to compare like this. I'll write this as 0 plus I times 0. 0 plus I times 0 is 0. So that means real parts, when you compare this is a real part because it has no I. This has to be equated. So I'll highlight once again. So if I want to compare the real parts, I'm supposed to compare the summation of cosine values. Right? Let's compare the sum of the cosine values like this. So simply use, I'll use a different color. So this has to be equated. So this portion, I'm going to compare it with this 0, right? So cos should be compared with the first 0, which is a real part. Both sides, if you are able to compare the real parts. Similarly, the imaginary part, whatever is there with I, that needs to be compared on both the sides. Okay, on both sides, I'll compare whatever is with I. That is summation k0 to n minus 1 sine of 2 pi k by n, that also should be equal to 0. So this is my conclusion that we can derive from this input. Okay, so this implies k is equal to 0 to n minus 1. K is 0 to n minus 1. The cos term, cos of 2 pi k divided by n, this has to be equated to the 0 on the right side, which is the real part. So the point is, if I take all the n terms and take their real parts and I take a sum, that is 0. Okay. Similarly, you take the sum of the imaginary parts of nth roots of unity. That is k is equal to 0 to n minus 1. It is sine of 2 pi k by n, that is also equal to 0. So sum of real parts of nth roots of unity is 0. Sum of imaginary parts of nth roots of unity is also 0. Okay. Okay, then let us try to all right. Then we have another important formula. Right, this is an expansion, sometimes useful. If you have a number x to the n minus 1, right? It's like x to the n is equal to 1 aಗುತ್ತೆ, right? Because you take minus 1 to other side, right? Which is x to the n minus 1 irodu, x to the n equal to 1 aಗುತ್ತೆ, which means x is equal to 1 to the power 1 by n. Once again, we are coming into the same point, that is nth root of unity is a solution. This can be directly substituted as, see, x minus 1 into x minus alpha into, see, x minus alpha square. See, each term is a nth root of unity, right? Last term should be x minus alpha to the power n minus 1. See, you are factorizing. If you know the n value, like x to the power 4 minus 1, so I have to write 4 terms here, x minus 1, x minus alpha square, x minus alpha cube, where alpha is equal to cos of 2 pi k divided by 4. N is equal to 4. Like that we can substitute, right? This is one important formula. Then let's go further. And right, other formula which we can use several times is this. Okay, we raise to the power p, right? So that means 1 to the power any number p plus alpha to the power p, right? Plus maybe alpha to the power 2p plus alpha to the power 3p and so on. Okay, up to alpha to the power n minus 1 times p. Okay, this answer can be directly asked, right? This answer is 0, right, if p is not integer multiple of n, and this answer is n itself if we can say that the p is if p is integer multiple of n, right? So anyway, we'll see that in problems later, but as of now let's just remember. Okay, so this is 0 under one condition, and at the same time this is n itself is, okay, this is n, say if p is integer multiple of n. That's next rule to be remembered. All right, then the next point to be remembered is 1 plus alpha, 1 plus alpha square, dot dot dot, up to 1 plus alpha to the n minus 1. Again, this can be directly calculated by using all the properties we have seen so far. This is 0 if n is even. N is even number means it's 0 directly we can write that. At the same time, if n is odd, this result is 1. Okay, this is 1 if n is odd.